Hello everybody, I am Syed on Maths Online. Today's topic is Lagrange linear PDE. In the last video we have solved few problems based on Lagrange linear PDE. We will continue with few more problems today. So we try to observe this equation is in the form of PP plus QQ is equals to R, where the value of P is nothing but x into y square minus of z square. Your value of Q is nothing but y into z square minus of x square. Your value of R is z into x square minus of y square. So if you write down the auxiliary equation will be equals to, it is dx by P is equals to, it is dy by Q is equals to, it is dz by R. That is dx by, you can write down the value of P. So the value of P that you have is x into y square minus of z square. That is equals to, it is dy by, the value of Q is y into z square minus of x square is equals to, it is dz divided by R value is z into x square minus of y square. So now we'll try to see if you can get any multipliers in such a way that when you add the other values it should become equals to 0. Try to observe here, you are getting y square minus of z square minus of x square minus of y square. It is in the symmetric form. Leaving this is the additional terms you have, x, y and z. Suppose if you can eliminate this x, y and z and add these values, then it becomes 0. So if you want to eliminate this x, that means you have to divide by x here. So dividing by x represents you have to use the multiplier as 1 by x, which means I am multiplying this by 1 by x in the numerator, 1 by x in the denominator, so that this x will cancel out. Similarly here also, y has to cancel out, you can use the multiplier as 1 by y. Here z has to be cancelled out, I will use the multiplier as 1 by z. So I am using the multiplier in such a way that when you add the denominator values, it should become equals to 0. So now let us try to see. The multiplier that I am using over here is 1 by x, first term into dx. The second term I am using the multiplier as 1 by y, so 1 by y into dy. The third term I am using the multiplier as 1 by z into dz. It's whole divided by. So I have to use the multiplier as 1 by x times of x into y square minus of z square. I am using the multiplier as 1 by y into y times of z square minus of x square plus 1 by z into z times of x square minus of y square. So we try to observe here, this x and x will cancel out, y and y will cancel out, z and z will cancel out. So it becomes 1 by x into dx plus 1 by y into dy plus 1 by z into dz. It's whole divided by. So the denominator value is y square minus of z square as first term. Second term will become z square minus of x square. The next term will become x square minus of y square. So try to see that this plus y square minus y square minus z square plus z square minus x square plus x square will cancel out. So in the denominator it becomes 0. So keeping this in mind, you have to consider the multipliers. So I have got 1 by x into dx plus 1 by y into dy plus 1 by z into dz. It's whole divided by 0. So hence you got 1 by x dx plus 1 by y dy plus 1 by z dz. Its value is equals to 0. So they are in the variable separable form, you can just integrate it. So you'll get integral of 1 by x into dx is nothing but dx by x plus integral of, it is dy by y plus integral of dz by z. And the constant of integration, as you know, that integral of dx by x dy by y and dz by z will turn out to be log. Therefore I'll take the constant of integration as log of c1. So this becomes log of x, this will be log of y, and this is log of z is equals to, that is log of c1. But as we know that log x plus log y plus log z is nothing but log of x, y, z is equals to, it is log of c1. So if I try to eliminate this log, I'll be getting the expression to be equals to x, y, z is equals to c1. So we have got the first solution. Let us take this as equation number 1. So using the multipliers, we got one solution. So now what should be the next multipliers? If we try to once again observe over here, x we have cancelled out now. The next multiplier you have to consider this x, y and z. If you try to observe the other terms, y square, z square, z square, x square, x square, y square, they are in terms of square. Now try to observe, can you make this as square terms? If you multiply this by x here, it becomes x square. If you multiply this by y, it becomes y square. If you multiply this by z, it becomes z square. So if I can use the multipliers x, y and z, then in that case I can get the solution. So let me use the multipliers as x, y and z. Use multipliers x, y and z. So x dx plus y dy plus z dz whole divided by, multiply x square inside, we'll be getting x square y square minus of z square x square, multiply y square inside, we get y square z square minus x square y square, multiply z square inside, it becomes z square x square minus y square z square. Now if you try to see, this x square y square minus x square y square will cancel out, minus z square x square plus z square x square will cancel out, plus y square z square minus of y square z square will cancel out. Therefore we got x dx plus y dy plus z dz whole divided by, its value will be equals to 0. So x dx plus y dy plus z dz, its value will be equals to 0. Now you can integrate it. It's integral of x into dx plus integral of y into dy plus integral of z into dz will be equals to, you can take some constant of integration to be equals to c2. So if you try to integrate, you will get x square by 2. Integral of y will be y square by 2. Integral of z will be z square by 2 is equals to c2. Or if you take the LCM as 2, you will get x square plus y square plus z square is equals to c2. Or x square plus y square plus z square will be equals to, if you cross multiply 2 on the other side, it becomes 2 times of c2. So let us take this as second solution. Now if you write down the final solution, it's 5 of. The first solution you have got it as x, y, z. And the present solution is x square plus y square plus z square is equals to 0. So that's the solution we have. The next question is solve x into y square plus z times of p minus y into x square plus z times of q is equals to z into x square minus of y square. So this expression is in the form of pp plus qq is equals to r, where the value of p is nothing but x into y square plus z, and the value of q is minus y times of x square plus z, and the value of r is nothing but z into x square minus of y square. Therefore the auxiliary equation will be dx by p is equals to, it is dy by q is equals to, it is dz by r. So it is dx by, the value of p will be x into y square plus z, is equals to, it is dy by your value of q will be minus y times of x square plus z is equals to, it is dz by r value is z into x square minus of y square. So now we need to see which multiplier to be used over here. If you try to observe here the terms which are outside x, y and z, can I eliminate this x, y and z? Suppose if I try to divide this by x, it will cancel out. Let me see. Suppose if I divide that by x, what will be the term? Y square plus z. So the first multiplier, if I am using the multiplier as 1 by x, I get this expression. Suppose if we use y, that means 1 by y as the multiplier, what will be the term that will be left out? Minus x square. You have to multiply this minus inside, minus x square minus into plus minus of z. Here if I use the multiplier as say 1 by z, so z will cancel out. What will be the term that will be left out? X square minus y square. So choose the multipliers in such a way that when you add the denominator values, it should be equals to 0. Let us try to see here. X square cancels out, y square cancels out, z will cancel out. Therefore this 1 by x, 1 by y, 1 by z as a multiplier can be taken. So use the multipliers 1 by x, 1 by y and 1 by z. So if you use the multipliers, I'll be getting 1 by x into dx whole divided by plus 1 by y into dy plus 1 by z into dz. So denominator I'm using the multiplier as 1 by x into x times of y square plus z. Here negative sign is there, so you can write negative outside. The multiplier is 1 by y into y times of x square plus z, plus the multiplier is 1 by z, so 1 by z times of, here you have z into x square minus of y square. So this x will cancel out, y will cancel out and z will cancel out. Now if you try to simplify that denominator expression, we will be getting the expression as so you have y square plus z here. A negative sign you can multiply inside, it is minus of x square. So minus into plus is minus of z, plus here you are left out with x square minus of y square. So this plus y square minus y square plus z minus x square plus x square will cancel out. So we will be left out with 1 by x into dx plus 1 by y into dy plus 1 by z into dz whole divided by the denominator is 0. So therefore we have 1 by x into dx plus 1 by y into dy plus 1 by z into dz. Its value is equals to 0. So they are in the variable subrule form, you can integrate it. So you'll get integral 1 by x into dx is nothing but dx by x, integral of dy by y plus integral of dz by z is equals to, so the constant of integration here it will be log of c1. So this becomes a log of x plus this will be log of y and this will be log of z is equals to, that is log of c1. So now using the properties of logarithm, log of x plus log of y plus log of z can be written as log x y z is equals to, it is log of c1. If I try to eliminate log from both the sides, we will be getting x y z to be equals to c1. That is the first solution you got. Now for the second solution you have to use the next multipliers. So let us try to see what multipliers can be used over here. Let us go back to the expression that we have. This is the expression we have. It is dx by x into y square plus z minus y into x square plus z into x square minus of y square. So what multipliers can be used over here? Now once again, as we have seen in the previous example, can I use it as x, y and z as the multiplier? Let us try to check it. If I can use x, y and z. So if you use x as a multiplier here, you will be getting x square. This becomes x square. So multiply x square with y square, x square, y square, right? Plus you get x into z or zx. Here if I am using the multiplier as y, so this becomes y square minus y square multiplied by x square will be minus x square y square. Again it is plus into minus minus y square into z, it is y square z. Here if you try to observe, in this case, see x square y square, however this term will cancel out, positive and negative in this case. You are having z into x square here. So we got plus z into x square here. This is minus, this is, we are using the multiplier as y, so this becomes y square. So y square into x square is minus x square y square. This is again y square into z will be minus y square z. Now here, should I use z as the multiplier? If I use z as the multiplier, it becomes z square. But you don't have z square here. That means you have only z value. So z value should be as it is. So which means if I'm just using the multiplier as 1 itself, so it becomes zx square. Zx square. But zx square, and you will be getting minus of again zy square or y square z. So if you try to observe here, x square y square minus y square x square will cancel out, but plus zx square and it's plus zx square. So which means this should be negative here. So instead of using plus 1 as a multiplier, if I use minus 1, this becomes minus, and this will be minus z, minus into plus, minus into minus will become plus over here, which means that I had to use the multiplier as x, I had to use the multiplier as y. Last case I would use the multiplier as minus of 1. Z will not work because we have seen over here. In that case, if you take z as a multiplier, you will not be able to make it as 0. So therefore you have to make the multiplier as minus of 1. So let us use the multipliers as x, y and minus of 1. So in that case the expression will become x into dx, y into dy minus 1 times of dz whole divided by. The first term is multiplied by x, so it will be x square times of y square plus z minus, it is multiplied by y, so y into y will be y square times of x square plus z. Minus 1 is the multiplier, so minus 1 into z will be minus z into x square minus y square. So therefore we get x into dx plus y into dy minus of dz, it's whole divided by. Now just multiply x square inside, you'll get x square y square plus zx square. Then multiply minus y square inside, minus x square y square, minus into plus will be minus of, it is y square z. So coming to this one, minus of, it is zx square, and minus of minus will be plus, it is y square into z. So now plus x square y square minus x square y square will cancel out. This plus zx square minus zx square will cancel out. Plus y square z minus y square z will cancel out. So you have x dx plus y dy minus of dz whole divided by, the denominator will be equals to 0. So hence x dx plus y dy minus dz comes out to be equals to 0. You just integrate it. It's integral of x dx plus integral of y dy minus integral of dz is equals to, the constant of integration will be equals to c2. So let us try to integrate this one. So integral of x will be x square by 2 plus integral of y will be y square by 2 minus integral of dz will be z is equals to c2. Or we take the LCM as 2 here. LCM is 2, so that becomes x square plus y square minus, just multiply the 2, so you'll get 2z is equals to c2. Or if we cross multiply the 2 on the other side, it becomes x square plus y square minus 2z is equals to 2 times of c2. Well, that's the next solution you got. Let us take this as equation number 2. This is equation number 1. Now the final solution will be 5 of, the first solution is x, y, z. The present solution is x square plus y square minus 2 times of z is equals to 0. So that gives you the solution for the Lagrange linear PDE. Those were the examples for the Lagrange linear PDE. Thanks for watching the video.